Okay, so this is the outline of what I want to present for you today. I'm going to start by talking about my personal experience just for about 5 minutes. And then I want to, there's a certain kind of reasoning, a logic behind making an inference to intelligent design. I want to make sure that we all understand that. So I'm going to explain that very simply. Then the third topic has to do with philosophical biases. And actually, this is critical. It's really critical because there's a principle that's adopted absolutely in Western science that most people don't know about. And I want to make sure you understand that because that plays a big role. And then the main part of the talk, I chose 5 recent scientific discoveries that impact this question about design in the universe. There's many more, and I could have spent the whole time on just one, but I thought it's better to just cover several at a high level, and then there will be time for questions at the end. So I want to just let you know that I became, a little bit about my story, I became a Christian follower of Jesus when I was very young. And it had nothing to do with science at that point. Growing up, I was interested in math and science, and so I studied that through high school and in the university and graduate school and then in postdoctoral studies. But as I grew up, there was little or no discussion about science in the context of faith for me. So there was something was missing. And during my university years, I began to learn about scientists and intellectuals who believed that there was scientific evidence, persuasive scientific evidence, that design in the universe is real. People like Michael Denton, Philip Johnson, Michael Behe, Steve Meyer, and others. And this resonated powerfully with my own thinking and my own knowledge. And it's become a big part of my life. I've been learning and speaking and discussing for about 30 years on this topic. And at the heart of this, on my perspective, at the heart of this is a personal choice. And it's not about science versus religion. And that's a point I'm convinced of, and I want to emphasize it. This topic for me has had a big impact on my faith, my life as a Christian. And I want to mention it in two ways. First, what I know now about the physical world invokes a constant awareness within me that there is a transcendent source of love and goodness. The rich life that we experience. I played tennis today. I really enjoy playing tennis. You all have things you enjoy doing. Music. All these things are actually a gift from God that, from my perspective, that are enabled by the constants of chemistry and physics, actually. And the more you learn about this, the deeper that experience is. So it makes me want to worship God almost all the time, because you can see his goodness all around me. It's like the difference between if you see a picture of the Grand Canyon in a book versus if you stand on the edge of the Grand Canyon and you see it, there's an impact. And it's had that impact for me. And I'd like to share that with others. The other aspect is we live in a world that, while we have the evidence of God's goodness, we live in a broken world, and there's tragedy, there's natural disaster. We all experience problems and the bad things of life. So you have all that going on, and if you lose sight of the fact that there is a source of good and a source of love in the world, you can become overwhelmed. And for me, I won't go into details, but the most difficult times of life, I've always, it doesn't trump the evidence of God's love and goodness. That's what I'm trying to say.
Mhm.
If you see this, if you recognize that it's in the world, it's in our existence, the bad things don't trump that. So I'd like to share that with others. When I speak about this subject, I really want to emphasize two things: that I want people to be knowledgeable about the subject, and I want the philosophical decisions to be in your own hands. Those are the two principles. So I don't necessarily want to argue with anybody. I'll be happy to explain what I believe and why. But I think both of those things are not true in general. In general, I think people are not knowledgeable about some of the most important discoveries that impact this topic. And for reasons that I'm going to explain in just a few minutes, I don't think the philosophical decisions are generally in the hands of the individuals. I think they're made for them by others, and I'm going to come back to that in just a minute. Okay. So now I'm going to move on to what is intelligent design? What is the logic behind intelligent design? And I'm going to explain this with an example that's trivial. It's very obvious. It's unambiguous. If you all see a car like this on the beach, we all know that where this came from. We all know this came from a mind. It was designed. Why do we know that? Well, we just know that because we know car companies make these things. We also know that because we know that the action of the wind and the waves rolling up and down on the beach for millions of years will never make that. It will never make that. Earthquakes, tornadoes will never make that. And the reason is because it shows a purposeful arrangement of parts. That's one way to say it. It shows a complex, it's complex, but it's also specified for function. And a kind of a generic way of saying that is it has a high amount of information in it. Mm-hmm. And we know just intuitively that that's beyond the reach of natural processes. We know, if you know a lot about physics and chemistry and engineering, you can know everything about how a car works, how it runs. But those same principles tell you nothing about where it came from, right? It doesn't tell you anything about because in this case, the origin of that object comes from a designing mind. There has to be an input of information to bring that about. So I want you to think about and appreciate the difference between how something works, how the natural world works by natural laws, and the origin questions, which may or may not involve information, an input of information. So there are many ways that people describe this kind of characteristic, purposeful arrangement of parts, specified complexity. I like this term that's used by an English mathematician named John Lennox in a recent book called Cosmic Chemistry. He referred to it as an informational discontinuity. Discontinuity with respect to what unintelligent natural processes can do. Unintelligent natural process can never make that. We know that's an obvious example of an informational discontinuity. So it's kind of a well-defined scientific question. Are there informational discontinuities? Do we observe that in our world? That's the question, and that's the kind of reasoning that's behind intelligent design. Now, I think everybody would agree that it's appropriate to ask the question, is intelligence involved in all these objects on the top of this slide? So the structures at Stonehenge, the faces on the cliff at Mount Rushmore, the Rosetta Stone, even signals from outer space, any kind of writing. So we do this kind of analysis of intelligent design all the time in our daily lives. And sometimes the answer is not obvious, but at least it's appropriate to ask the question, because the source of information will come from within the universe. But if you ask the question, well, why not ask the same question and use the same logic for these objects down here? Then some people would say that's no longer appropriate to ask that question. And this is a machine that bacteria use to swim, the genetic code, a gear structure that insects use to hop. And this is a diagram of the genetic regulatory network of the cell cycle of a bacterium. It's a very high level diagram of that. So why is it the case that it's okay to ask the question up here for these objects, but not here? And it's a certain group of people would say that that's not appropriate. And I'm going to come and answer that question and why they think that way in just a minute. I use the term informational discontinuity, and the term information I'm using there is kind of fuzzy. And how do you define information in terms of the faces on the cliff or the structure at Stonehenge? But when you talk about genetic information is mathematically shown to be equivalent to a language, a written language. And that was shown by Hubert Yaki. So it's not an analogy, it's exact mathematical equivalence. If we see a book, we know there's a mind behind it. And it's the same mathematical equivalent structure in genetics. So, from the design perspective, intelligent design, we feel it's appropriate to ask that question. Why not? But I'll explain the problem in just a minute. Within the last 50 years, I would say within the last 100 years, there's been a really intense period of scientific discovery. There's been lots of scientific discovery throughout history, and there will be in the future. But this period of time, within 50 years of my lifetime, 100 years, let's say, there's a very intense period of discovery. And through that period of discovery, I believe it's not controversial to say that the number of things that have been discovered that seem to be informational discontinuities has increased dramatically. I'm going to talk about 5 today, but there are many, many more. And that's why this movement of intelligent design is having a lot of impact around the world because the evidence is increasing. That's my perspective. Okay, now I want to talk about philosophical biases. And I know the blue boxes are not showing up super well, but I'm just going to, there's a principle in the philosophy of science that I want to illustrate with a couple of diagrams. And the diagram on the left is what I would call an open philosophical view. Now, the box on the right is a box that says nature is all there is. So nature is defined by matter and energy, space-time, natural laws. And there's a philosophical perspective which says that is all there is. There's nothing else. It's complete. And on the left, there's a box that says, well, maybe there's something else, something outside of nature. And of course, that's theological, but it's also a philosophical position. And so that in that view, nature is not there's an incompleteness to nature. And the red arrow is science. Science is just a method. We're all on the side of science, and within this perspective, it's at least possible for scientific evidence to point one way or the other. I would think we'd never say you prove it, but you can gather evidence, and the arrow can point one way or the other, and it's possible. Now on the right is what I think is a common misconception, where you have these, it's seen in terms of these dichotomies like science versus religion, faith versus reason, naturalism versus theism, rational objective reality versus irrational subjective fantasy. So it's often messaged that way to the public. And in this view, science can only be on one side. And inferring design from something outside of nature would always be unscientific by definition. Okay, this principle that I want to emphasize is wonderfully illustrated by this quote by a biologist named Richard Lewontin. He was a very influential, he just passed away recently. He was at Harvard. He was a very senior figure in the biological community in the US. And he was reviewing a book by Carl Sagan, and he wrote this in 1997. And he's talking about this philosophical principle. He says, we have a prior commitment to materialism. It's not that the methods and institutions of science compel us to accept a material explanation of the phenomenal world, but on the contrary, we're forced by our a priori adherence to material causes to create an apparatus of investigation and a set of concepts that produce material explanations, no matter how counterintuitive or mystifying to the uninitiated. Moreover, that materialism is absolute, for we cannot allow a divine foot in the door. So Richard Lewontin doesn't have the perspective that I'm showing here. And what he does is he removes the other box from the page. It's simply not allowed as a possibility. And when I saw this the first time, I thought, well, what's wrong with a divine foot in the door? If that's the truth, wouldn't we like to know that? And whose job is that to decide for the rest of society whether that's allowed or not? And when he says we can't allow it, or we have, who's we? So I was a professional scientist, and I don't feel this way. Who's we? And what does it mean when he says we can't allow it? So these are all strange things from my perspective, but this is encapsulated in the term methodological naturalism, which is a term which is a philosophical principle that is adhered to in an absolute sense in the Western science world, I think, as far as I know, all the Western countries. And if you Google the term, this is what it says. Methodological naturalism is a philosophical doctrine that states that scientific explanations should only use natural causes and should not reference God or other divine activity. It's a convention of science that aims to make science religiously neutral and separate from theology. So you have to think about this personally. What do you think about it? If you don't allow any scientific evidence ever to be considered as pointing toward something outside of nature, God, is that religiously neutral? So you have to think about that. And is it even good for science? I mean, if the answer is that there is an input from outside of nature, I think it's important for us to know that. And why constrain science arbitrarily? And another important point is, do you want others making this decision for you? Because if most people on this topic, they don't learn and make their own decision, they just choose an authority to follow. They choose an authority. And if you choose the scientific messaging, they make the decision for you. Because they've adopted methodological naturalism. And you might wonder, well, how bad can it get in science before this principle could be relaxed? And this author wrote a letter to Nature. Nature is the top journal in the world in science. And it was during a time of, debate. And he said, even if all the data point to an intelligent designer, that's excluded from science because it's not naturalistic. So you see, for some people, if you embrace this principle, it's not a question of evidence. It has nothing to do with the evidence. It's a philosophical principle that's adopted independent of the evidence. Okay, and it's important to understand that because as you'll see in some of the examples I'm going to show you, there are some people who are compelled to the design inference by the data. And some people see the data, they realize the impact of the data, the power of the data, but they just say, I can't go there. It's a personal decision. Okay, if materialism isn't true, if it's not true, if there is input from outside of nature in some sense, some information, then as science progresses, it's going to reach a point where it looks like you have to choose between what seems to be impossible. Let's say the origin of life, in my opinion, it's in that ballpark. It looks, as you make more progress, you learn more, it just looks more and more impossible, but the alternative is unthinkable. So you're stuck between the impossible and the unthinkable. And I think that's where a lot of the science is in the areas of the discoveries that I want to go over. So now I'm going to try to march through several of these discoveries, 5 of them. And I think these are discoveries that a lot of people don't really know about them. And I think that in itself is interesting and surprising. Even people who are in science. Some are well known, but some are not. Okay, the first is that the universe, which is defined by the space-time continuum that we live in, the fabric, matter and energy, that had a beginning. And this is a diagram that you'll find. I think it comes from NASA, but it's on the web in various places. And it's a diagram showing really 2 sets of data. Let me see. Yeah, there it is. Okay. This part of it is what you see with telescopes. So the Hubble telescope, the James Webb telescope, you look up, you see lights in the sky and they come from galaxies. And the x-axis is the time axis. And so some of those points of light come from very, very far distances. So you're looking back in time. The second thing there is that blue-green color. And that's another form of radiation which we detect with other kinds of probes called the microwave background radiation. These are the two of the main measurements that people make to understand about the universe, the early stages of the universe. So that picture of an expanding universe comes from 4 observations. The first one is with telescopes, we see light from large distances. The second is that, and those points of light are moving away from us. And the wavelength of the light of those in all directions, the light coming from galaxies are moving away from us, and it's shifted toward the red side of the spectrum by a factor that's proportional to the distance. And so that means that it's it means that those objects are moving away at higher velocity if they're further away. The further away, the larger the distance, the higher the velocity. And the data for that as of 2003 is shown on the lower right. That's data from a PNAS article, National Academy of Sciences article. If you can think of this as blowing up a balloon. If you have a balloon and you take a magic marker and you draw a wave on it, and you blow it up. As you blow it up, the wave stretches, and it's exactly that picture that fits the data. And so these wavelengths are getting stretched, and that's why we see this redshift. Now, the third evidence was really important. In addition to these observations, there's also Einstein's theory of general relativity, which demonstrated or the solutions of that equation indicated that it couldn't be static. The universe couldn't be static. There's a story behind that, but I won't go into that. But so people realized if this story is really true, that the universe is expanding, then if you go backwards in time, it contracts and the temperature goes up higher and higher. And there's a point where the temperature would be 300 degrees Kelvin. And it's known in science that at 300 degrees Kelvin, 3000 degrees Kelvin, the protons and electrons dissociate. So they make a plasma. So there, at that temperature, there's a transition that's well known in science between a plasma and the recombination of protons and electrons. And if that really happened in history, then at that moment, light would be given off and the light would be free to propagate, because in a plasma, the light gets absorbed and interacts with the charged particles. So it was predicted if this really happened, there should be this echo from that event. And it was a really risky prediction. They just took this known temperature and they estimated the expansion of the universe, and they got estimated 5 degrees Kelvin, and the wavelength distribution of that radiation is known to be a black body radiation, a pure energy spectrum, and it was discovered by accident by these two guys from Bell Labs. So they got a Nobel Prize. It was one of the greatest discoveries of all time. And this is the spectrum of that energy. The dots are the data, and the line is the predicted spectrum. It's a perfect fit. And it actually came out at 3 degrees rather than 5 degrees. So, but this was just really convincing that transition really happened. So the universe really did go through this period of expansion. Now, the fourth discovery that relates to this is that so that radiation, that background radiation is indicative of the mass distribution in the universe at that time. And if it were perfectly uniform, then you wouldn't expect galaxies to form. Galaxies couldn't form. Galaxies form due to gravity, particles clumping together. So there has to be a little bit of non-uniformity in this. And then, so there was a lot of scientific effort put into the first probe and then subsequent probes to look for these fluctuations. And it was discovered in 1992. George Smoot led the group, and he won the Nobel Prize. And these fluctuations, the colors look really distinct, red, but it's actually 1 part in 100,000. So it's a really small fluctuation, but they're there. And so when he discovered this, it was he described it as something like looking at the mind of God or the fingerprints of God or something like that. And I'm going to come back to the special characteristics of this. It's very important, but I'm going to come back to that on the next discovery. So this all indicated that the universe really, there's an arrow of time and the universe had a beginning. And you might ask, well, what happened before the period of the cosmic microwave background? And that's illustrated in this diagram. The white arrow is where the background radiation is released. And to the left of that is higher energy. And higher energy, to experience that, you have to use particle accelerators. So all the work with particle accelerators to establish the standard model of particle physics, which is really solid today, that goes into speculating out to about here. But once you get here, you're really beyond observational science. And I'm going to come back to this period called inflation, and I'm going to explain where that comes from. But you're really, the edge of observational science is really right about there. In addition to these discoveries, there were two theoretical developments. Stephen Hawking and Roger Penrose and another collaborator. Right after Stephen Hawking finished his PhD thesis, he continued. They were applying black hole physics to the origin of the universe. Right. And they proved that using general relativity as the gravitational theory, that there would be a singularity in the space-time. So the radius of curvature would go infinite, or the curvature would go infinite and the radius would go to zero. And so that was a remarkable result. There's a singularity in time and also a singularity in space. However, people then pointed out that, wait a minute, general relativity, it only works until the whole universe is at a radius of 10 to the minus 12 centimeters. And then that theory could break down. So if you really want to push this idea even further than the whole universe being in a radius of 10 to the minus 12, that's less than an atom, the whole universe being that small, well, okay, maybe you need a quantum theory of gravity to really prove it. So this is a very powerful indicator of a near singularity, but not absolute because of the uncertainty about that theory. However, in 2003, these other scientists, Board, Guth, and Vilenkin, published a generalized proof for an origin, which has nothing to do with a theory of gravity. It's only based on special relativity, and it's a geometric argument. And so the only assumption is that it's for an expanding universe. And so when they published this, one of the authors said, with this proof now in place, cosmologists can no longer hide behind the possibility of a past eternal universe. There's no escape. They have to face the problem of a cosmic beginning. And this idea of a cosmic beginning, okay, so a universe that comes out of nothing, is that an informational discontinuity? It seems like a big divine foot in the door. But the reaction of many scientists was that they hated it, actually. They hated this result. And you can see some of these quotes. And actually, I don't want to go into this, but there's a book that describes a lot of persecution of scientists in Russia that happened who are following this theory. Anyway, Stephen Hawking in his book said, many people don't like the idea that time had a beginning, probably because it smacks of divine intervention. So there's a clear issue here with what you're willing to accept, what you want to believe. But this was earth-shattering to realize that prior to discovering that the universe is expanding, a lot of scientists just thought time never had a beginning. And so this was worldview changing stuff. However, for people who are not constrained by methodological naturalism and you're open to something outside the universe, there are some remarkable correspondences between what's been discovered by science, entirely empirical data from science, and what we read in the Bible. Is some remarkable correspondences. For example, there are many verses that talk about before the beginning of time. And if you think about it, it's just a very strange thing for someone to think 2,000 years ago, there was no general relativity. Why would you think there would be a beginning to time? It's an unphysical concept at that time. But it's in there. And then, of course, Genesis 1 talks about the beginning of the universe. Hebrews 11 talks about the universe was made at God's command, so that what's seen was not made out of what was visible. Mm-hmm. And this idea of the expanding universe, it fits so well with, there are 12 verses from 5 different books in the Old Testament that use the language of God stretching out the heavens like a tent, like a fabric. And it could be just poetic language, but for me, it really fits. It really fits the discovery of science that the universe, the fabric of universe is expanding. So now that was the first discovery. I'm going to move to the second one. And the second discovery, in my opinion, is the most important of all time. I think the first discovery is really huge, but I think this one is even more important because it touches on everything. And this one is that the laws of physics, the fundamental constants, and the initial conditions of our universe are really special. They're really special. And they're fine-tuned to allow for the possibility of life. And so this is speaking about the ability to have a stable periodic table of elements. It could very easily be the case if the numbers were slightly different, then you would have only hydrogen, or you would have no hydrogen and nothing but the higher elements. And the ability for chemistry even to be possible depends on these numbers of physics. And to have a universe that's filled with galaxies and stars that burn for long periods of time. That's not trivial. It depends on the numbers of these constants. And so this fine-tuning of constants and also initial conditions is another informational discontinuity, in my opinion. This is, by the way, all these discoveries that I'm telling you, they're not controversial. Nobody would, I think, almost nobody would disagree with any of these. They just disagree about what do you make of it? What are your conclusions? So this fine-tuning started in the 60s and 70s when they were developing the standard model of particle physics. But I'm just showing you some books from 2006 forward. The Goldilocks Enigma is one of my favorites by a person who's not an advocate of design, but he's just a great scientist and he's very honest about it. The last two are really great. And they cover both Discovery 1 and Discovery 2. But I'm just gonna give you a few examples. We could spend the whole hour and a half just talking about this. But I'll just give you a few examples. There are 4 forces of nature. There are 4 forces that we know about that describe all the forces of nature. There are 4 forces of nature, and they have each a magnitude. And the ratio of those magnitudes turned out to be very important. And I can explain some of this during the question and answer. I'm not gonna go into all the details, but it has to do with the stability of the nuclei. And if the ratio of the strong force to the electromagnetic force, so there's two forces in the nucleus, and there's the electromagnetic force, which is the one that we have most experience with, and there's gravity. And if the strong force relative to the electromagnetic force was a little bit higher, we would have no stable hydrogen. Hydrogen wouldn't be stable. You'd have all the protons and neutrons, it just wouldn't be stable. They would form higher elements. But if that were less, a little bit less, there would be no elements other than hydrogen. And Stephen Hawking talked about this fine tuning in his book, and he mentioned so the masses of the fundamental particles also are very fine tuned. So speaking of the mass of the proton to the mass of electron, it has this ratio, and that ratio determines the characteristics of orbits of electrons. If it were slightly different, there would be no chemistry. Chemistry wouldn't be possible. And he cited that in his book as one of many important fundamental numbers of nature. And he wrote, the remarkable fact is that the value of these numbers seem to have been very finely adjusted to make possible the development of life. He's not an advocate of design. I think you know that. And this slide shows three more. The ratio of the neutron to the proton matrix is 2 to 1 part in 1,000. The weak nuclear force to the strong nuclear force, 1 part in 10,000. Electromagnetic force to gravity is tuned to 1 part in 10 to the 40th. These are huge numbers. This is not controversial anymore. And Paul Davies, who's not an advocate of design, he writes, the really amazing thing is not that life on Earth is balanced on a knife edge. We're going to come to that topic in a minute, but that the entire universe is balanced on a knife edge and would be total chaos if any of the natural constants were off even slightly. And most people don't know about this. I'm surprised. I mean, it's one of the greatest, I think the greatest discovery of science that most people don't know about. Now, in addition to the constants, the initial conditions are even more special. And so this background radiation that we discovered actually has characteristics that are I would say on face value, they're miraculous because there are three. The first one is that it's called the horizon problem. So we measure this radiation, light coming, it's everywhere, and you can measure it in one direction from the Earth and the other direction from the Earth, and you're measuring photons that were from 13.7 billion years ago. So those two parts of the universe were not in causal contact, but they're at the same temperature. So how can something be at equilibrium if they're not in causal contact? And that was just a mind-boggling result. The second one is that from the characteristics of these little fluctuations, scientists can determine whether the geometry of the universe is curved in one direction or curved in the other direction like a saddle, or if it's relatively flat. And that's important, and that depends on the mass energy density of the universe, because Einstein's theory, mass energy, curved space time. And if there isn't a very precise balance, then a universe that were not flat, if it was curved very much, then it would very quickly collapse in on itself. and you'd have all black holes, and the universe wouldn't be functional. It wouldn't have galaxies, and it wouldn't be long-lived. If it were curved on the other side, you wouldn't have any structure. You would have just particles. And so it's known that in order to have the universe, so we have a flat universe, and it's basically 1 part in 10 to the 60th in the mass energy density. And so why? Why does it have that value? Nobody knows. But this was the second problem. And the third is that these fluctuations, actually the magnitude of those fluctuations have to be in a certain range in order for, to avoid all black holes or to produce galaxies and long-lived stars that we have today. And there's an article that didn't get that's referenced here that's kind of grayed out, but that was an article that pointed out some physicists measured that if those fluctuations were a factor of 10 higher or lower, our universe wouldn't be suitable for life. So there are these three and this is probably the earliest thing we can ever measure. So the earliest thing I say probably because there's still a possibility that there's a neutrino background or there's gravitational waves. Those are very difficult to measure. Probably this is the earliest thing we'll ever measure. And it looks like it's a miracle, really. And so in order to avoid a theological conclusion, scientists came up with a theory called inflation. You may have heard of that. And inflation is this period right in the beginning where you go from a real tiny universe to a really, really big universe in an instant. And that is a clever way of explaining all three of these. I won't go into the detail, but you can feel pretty good about those three observations if this really happened. However, that inflation requires even more fine-tuning. You can't avoid it. And in fact, it's just astounding. The practically the minuscule fraction of universes that would end up looking like ours in an inflationary scenario that included quantum fluctuations. So this is not even considered by many people within the realm of science because you can't measure any of the details of this. There would have to be some sort of field, and it'd have to be shut off at the right time and with exactly the right energy. So it's really it might have happened. I think God stretched out the heavens, and whether it happened is one thing, but whether it happened naturalistically, there's no way to reach that conclusion. There's no naturalistic, plausible way of coming up with that fine-tuning. So, and then actually the greatest example of fine-tuning is the entropy of the initial state of the universe. So this was calculated by Roger Penrose, and nobody doubts this that I've ever seen. And if you think about this, the whole universe supposedly was in the size of an atom or something like that. But it's not a black hole. Why isn't it a black hole? It's not a black hole because it's perfectly uniform. So a black hole has the highest entropy of anything we know of in the universe. And so he took the ratio of the initial entropy of the universe to the entropy of a black hole, and he argued that the initial state of our universe has to be tuned to 1 part in 10 to the power 123rd. And it's a calculation you can look up on this. So there's no ambiguity or the initial condition of the universe is just miraculous. And that's just the result. Okay, and so now people respond to this differently. So this is a quote from one of these two guys that discovered the cosmic microwave background radiation. He said, astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying supernatural plan. So that's a conclusion they come to. I'm going to give you two more examples. Alan Sandage was an observational astronomer. He was actually a student of Edwin Hubble. And so he spent his whole career measuring that Hubble constant. And he described his change of view, basically. He said he describes it as a supernatural event. And he says, I now have to go from a stance as a complete materialistic rational scientist and say this supernatural event to me gives credence to my belief there's some design in the universe. So he didn't start there, but that's where he ended. And Fred Hoyle is another example. He was the person who discovered the very first example of fine tuning in one of the constants of physics. And there's an interesting story about that. But he was a staunch atheist through most of his career. But he changed his view at the end of his life. He said a common sense interpretation of the facts suggests that a super intellect has monkeyed with physics, as well as chemistry and biology, and there are no blind forces in nature. The numbers one calculates seem to me so overwhelming as to put the conclusion beyond question. Now, I'm going to show you some examples now of people who see the same evidence, but can't go there. Can't go to that conclusion. So Robert Jastrow wrote a book called God and the Astronomers, and he wrote this at one point. He said, for the scientist who has lived by his faith in the power of reason, the story ends like a bad dream. He scaled the mountains of ignorance. He's about to conquer the highest peak. As he pulls himself over the final rock, he's greeted by theologians who've been sitting there for centuries. So he sees the theological implication. He says it. But in a video interview that I could show you, it's on the internet. He said explicitly, but I can't accept it. He said, I'm a materialist, and I can't accept that. So it's his choice. It's his personal decision. And a similar thing by this astrophysicist who wrote a book about the same time. And he said, as we survey all the evidence, the thought insistently arises that there's supernatural agency. Is it possible that we, without intending to, stumbled upon the scientific proof of the existence of a supreme being? Was it God who so providentially crafted the cosmos for our benefit? But if you read a little further in his book, he says he rejects that for philosophical reasons.
Oof.
So you see, you have evidence, and then you have a personal choice. But if you just follow what the scientific community messages to you, they adopt methodological naturalism. And so they make this decision for you. Okay, now the fine tuning of the constants, of the force constants, to me is interesting to think about in the context of the Colossians 1:15 and 16, where it says, by him all things hold together. And I don't know how you can interpret hold together in a way other than some forces are involved. So in physics, it's a mystery why all these forces have these numbers. But by him all things hold together. He sustains all things. That's another similar kind of passage. Okay, so with these two first discoveries, it's unavoidable that something really, really amazing has to be true. And so what are the choices? One is there's a mind outside. This is information from outside the nature. The universe began and it's fine-tuned. And most people would call that God. Another belief is that, well, maybe there's an infinite number of universes and all this can just be by chance. And that's equivalent to saying that car just appeared on the beach with no explanation. Some universes, cars just appear on the beach. And that's exactly what that perspective is. Now, more and more people are starting to adopt the third position. If you don't want to believe in God, there's the idea that we are a computer program. Because they recognize that there is an informational discontinuity, but they can't believe that it comes from outside. So maybe there's a computer programmer within nature supplying the information. And I want to show you it's not a crazy thing. Well, I want to show you that a lot of people believe it. Because this is an article from BBC Earth, and it was ranked as the best of 2016. And the title is, "We Might Live in a Computer Program, but it may not matter." And I'm just going to show you one section from that. Some scientists argue that there are already good reasons to think we're inside a simulation. One is the fact that our universe looks designed. The constants of nature, such as the strength of the forces, have values that look fine-tuned to make life possible. Even small alterations would mean that atoms aren't stable, stars wouldn't form. Why this is so is one of the deepest mysteries in cosmology. So it's not controversial. But very few people know about it. Okay, now I'm going to move more quickly through the other three discoveries. The third discovery that I want to present to you, it has to do with our planet, actually. Today, it's known now that there are so many highly improbable factors that make the Earth habitable that it's very, very unlikely that there's another truly Earth-like planet, we can say, in our galaxy, and some people say even in the universe. This is a quote from a book by a person who's not an advocate of design. And he says, "The Earth is a precious jewel in space. It has a rare combination of qualities that happen to make it almost perfect for life." He says he no longer has doubts. The evidence points to the Earth being a very peculiar place, perhaps the only highly habitable planet we'll ever find, almost too good to be true. So, but sometimes I think you may have read that there's so many Earth-like planets. I think you've heard that. Okay, I'm going to explain that to you. So, if you think the number of planets in our galaxy is about 10 to the 11th or 10 to the 12th. And if there are 6 factors that have 1 out of 100 chance and they're independent, then you get to 10 to the 12th. And you would say that you have no right to think there's going to be another Earth-like planet in the galaxy. And so I've been collecting data from published papers on this topic. And if we could spend the whole hour just on this topic of our planet. So I'm just going to pass this very quickly. Things like the type of star, the moon, the characteristics of the other planets, the radioactive materials in the core of the Earth that affect the plate tectonics and the magnetic field. The one thing so the people who say there's billions of Earth-like planets, they just take this first factor. The number of Earth-sized planets in the habitable zone, and there's an estimate that something like 22%. But they just take that factor, and they don't consider all the other things that are essential. They're necessary. And so now it's known that that's really deceiving. It's really deceptive to say that. There's a lot of really important things that we can't assign numbers to, like just the right amount of water, the core mantle and crust characteristics, the right amount of carbon, and the atmosphere. So there's a lot to say about this, but we don't have time today. And if you just take the numbers that I can get from the literature, it comes to 2/10⁻². So it's very clear to me that there's not going to be an Earth-like planet in our galaxy. At least unless it's an act of God, I think. There's no reason to think of from science perspective. Now, this was controversial at one time. So there was a book that came out, Rare Earth, 2000. It was kind of a controversial idea. And then these other books came out. But in 2018, National Geographic published both a video series and an article saying it's called One Strange Rock. And you can find it, and it lists all these factors. And I just came across this book from an astrophysicist in France who wrote it in 2022. And the title of this is Alone in the Universe. And he's not an advocate of design, but he recognizes our planet is unique. So the last thing I want to say to you about this is that there's one more thing that's really important. Our planet is not just at the limit of habitability. We flourish. We have so much more than just being at the limit. Just from a statistical perspective, you would expect the probability would be you'd be just on the limit of habitability, not having all this richness, it's too good to be true. Okay, so I think the exceptional habitability of the Earth is now, it's not controversial that the Earth is unique. It's a question of the numbers. Is it 1 in a million? Is it 1 in a billion? Is it 1 in a trillion? What's the number? As I was showing in that calculation. Okay, now again, there are wonderful correspondences with things that were written in the Hebrew scriptures thousands of years ago. And then my favorite verse on this topic is Isaiah 45:18, where it explicitly says, God made the earth to be habitable. And if you think about that, the concept of habitability, everything they knew was habitable. They didn't know what was out there isn't habitable. So even the concept of habitability is not really something that would have been easy for them to come up with. So I think there's a good explanation here, or at least it's a correspondence that between the Bible and what science has discovered that's, I think, remarkable. Okay, now I'm going to say a few things about life very quickly. Number 4 is something everybody should know, is the number of genes in the simplest free living organism is about 450. It's just a fact. Everybody should know, but most people don't know that. 450. Where does that number come from? I'll explain it. Before I explain where the number comes from, all life is based on cells, and the simplest cell has certain things that it has to do. It has to get raw material and fuel, it has to eliminate waste, it has to convert raw material to useful things, build machines, repair damage, copy and protect genetic information, divide the cell, and it has to coordinate all these things. And there's a machine or a system of a machine for every job, and there's a system for making machines, the central genetic apparatus, and there's a system of coordinating the machines. And all that's necessary. So the measurement, so that came up with this number, 473 genes. This was done by Craig Venter. So Craig Venter was he led the private effort to sequence the genome. There was a public effort led by NIH, Francis Collins, and there was a private effort led by him. And he developed the technology to synthesize an entire genome. Before this time, it was very, very common for biologists to put genes into organisms, synthesize genes and put them in organisms. That was done all the time. But he synthesized the whole genome. And so he removed the genome from a very simple organism. When I say very simple, I didn't really mean that. From the simplest organism, Mycoplasma mycoides, has about 901 genes. He removed those genes and he synthesized that genome and he put that into another organism from which he removed its genome. So it's a genome transplant. It's like you get a heart transplant or a liver transplant. This is a genome transplant. So there's no, from an information perspective, there was no new information. He just copied it, made it synthetically, put it in, and it worked. But so the organism could reproduce. With that technology, then he could cut out genes. He could knock out genes and find out, well, how many can I eliminate before this organism can't live anymore? And his group did that in several cycles. And what they found is that they could get down to 473, and then the organism couldn't live anymore. And this pie chart shows you what those 473 genes are doing. So almost 200 of them are involved in this expression of genetic information. At least 50 genes about 50 genes are involved in the ribosome. That's the machine that makes proteins. So a lot of genes have to be there to express genetic information. And okay, 34 genes are there to protect the genetic information. There has to be a system to repair damage, to be robust. Cell membrane, there's 84 genes that controls what goes in and out and signaling from outside and inside, and metabolism, 81 genes, and there were about 80 genes that they didn't assign. So the bottom line is there is no such thing as a simple form of life. There isn't. 400. So just remember what 473 genes. And this author expressed it this way. He said, we now know not only of the existence of a break between living and non-living world, but it's the most dramatic and fundamental of the discontinuities in nature, informational discontinuity. Between a living cell and the most highly ordered non-biological system like a snowflake or a crystal is a chasm as vast and absolute as it is possible to conceive. So what do people say about the origin of life? I know that's a topic that your group is hearing more about, and that's great. So these are the possibilities. One is most people, so I just want to make this clear. Nobody, no scientist would ever think that bacterium could happen just by chemistry. That's out of the question. Nobody thinks that. So what people think is there must have been some sort of simpler form of life that came first that we don't have anymore. We don't see it. Another idea, and I can show you a paper from a high-ranking biologist who proposed that, well, maybe we can just say an infinite number of universes, it happens. It's the car just appears on the beach. And he published that in a journal. I could show you that. Another one is life is seeded by aliens, but where the aliens come from, that doesn't really help you. Then there's the computer programmer. There's an information discontinuity, and it was typed in by a computer programmer, or it comes from outside the nature, and that would be God. I just want to say very quickly this idea that you have some simple form of chemistry that goes between, so here you have chemistry, and then there's this idea that there's some kind of self-replicating autonomous chemical system that's vastly simpler than an organism. But that's and they think that if you can make that, then you can just believe that natural selection will do the miracles and make the rest. well, I don't think there's any reason to think natural selection can do that. But nobody can make a chemical system that satisfies that. And the progress that has been made, in my opinion, in RNA world, there are some really clever things that they do with RNA, but they're designed actually, and the further they go, the more design has to be put into it. So it already represents an informational discontinuity. And it's far, far, far from being a system that's autonomous and so there is no such thing as a chemical replicating system. And probably, and I don't know whether there ever will be or not, but the distance between chemistry and the simplest life we know is just unimaginably great. And the progress, so the people who work on this project, on this problem, they think about it in terms of chemistry. It's a chemistry problem. If we can just do something with chemistry, they don't think about it from an information perspective because you can't. What could you do? There's nothing. So all the progress that's hyped is about little things having to do with chemistry, and I think your other speaker is going to be talking about that. So, okay, and these are some great books. Not all of them. At least 3 of these are from people who are not advocating design. Steve Meyer wrote the 3rd one. That's a great book. And the last one is also a really good book. Okay, the 5th one is just that those 473 genes are not just random proteins. They're machines. And they're in themselves miracles, actually. And I think I'm running out of time, so I think I just wanted to make sure everybody knows that inside of us, there are little molecular machines. I don't know if everybody knows that or not, but this is one there's millions of these in every other cells of our body, and this makes ATP. ATP is like the gasoline molecule that runs your chemistry. And these colored things are all proteins, and this is a circular machine. It's a rotary machine that runs on a proton gradient. It makes it turn, and as the shaft turns, the shaft makes enzymes flex, and that's what makes the enzymatic reaction happen. And so it's a machine. It's just like the car. There's a lot of parts that have to be there that are designed to make this work. Where did this come from? And when I was working, I went to the Biophysical Society meeting every year, and there's a whole session called Molecular Machines. And every year there are new machines, and the biophysicists figure out all the details of how they work. So everybody should know there are molecular machines, all kinds of them, in every living thing. And maybe you've already seen this, but this is another rotary motor that bacteria use to swim. Again, it's about 50 protein parts, and it's considered to be one of the most amazing machines in the universe. But there's just so many. We could spend the entire time just talking about molecular machines. Okay. I'm going to quit now really quickly, but I want to tell you that the software is just as amazing as the hardware in cells. But I don't have time to talk about it. And there's a revolution in biology going on with all the RNA, the role of RNA in genetic regulation. It's a deep subject. And it's amazing, but I think this is just a very high level diagram of the genetic regulatory network to make a certain bacteria replicate its cell cycle. Okay, just as with the cosmology discoveries, there have been people who switched their views based on molecular biology. And probably the most famous one is this guy, Antony Flew, because he was a career atheist debater. He spent his whole career debating against theists. And at the end, near the end of his life, he announced to the world that he changed. He believes there's a mind behind the universe. And it was shocking because he was the voice for the other side. And he said it was because of all the molecular discoveries of molecular biology. And other people have also changed their views. But again, there's Richard Lewontin. He knows as much as anyone about molecular machines and the simplest form of life, but he can't allow a divine foot in the door. That's a personal decision, though. It's not something that should be imposed on anyone else. Okay. And there's just many quotes about letting God back in, or the dreaded T word, teleology, should be excluded from science. So, okay, so where do these informational discontinuities come from? You can believe in a multiverse, you can believe in a computer programmer, and there's a part of this which is missing, which is John 1:1, where it says, in the beginning was the Word. So there was information from outside that was there at the beginning. And so those are choices. People should, I want people to be knowledgeable, make your own decision. But don't just, it just offends me to think that so many people follow the messaging of the scientific community, which adopts methodological naturalism. So that choice is imposed on you by someone else. Okay, I'll stop there. Thank you.
Awesome.
You have time for
Yes,
some questions?
sure. Sorry I ran late, but I'm having time for questions, sure. Back there?
So in your professional career, as I guess a biologist or some biological sciences, did you run afoul with your colleagues or with the higher ups based on your faith?
I have some things to say about that. Thank you for the question. So, Mark mentioned that 2002 and 2003, I taught a class at the university with a psychology professor. And it was taught for 2 years, and it was very highly rated by the students. But it was mentioned in a Wall Street Journal article, just a passing mention. There was a time of debate, and so that, because it was mentioned, some professors at the university, just a few, went to the provost and said, look, we're never going to get grants again. We're going to have terrible reputation. And so that's why the class ended. It was terminated. Where I worked, I did invite some of these scientists to come to Sandia. And one time I invited Doug Axe, and Doug Axe made a discovery that I didn't talk about related to proteins. And I advertised that he was going to come and talk about his paper. He published a paper in Journal of Molecular Biology. And the night before the presentation, I got a call at home about 10 o'clock from a guy 2 levels up from me in management saying, what are you doing? What are you doing? Because another staff member who is on the other side, kind of the adopting methodological naturalism, and feels that this whole thing is an attack on science. He says, that person went to the director and said, this is terrible. And so the director called me at home, and I told him that he published a paper. He's going to talk about his paper. And so they let it happened, and it was a nice event. But then I was told, don't ever do that again. So, but on the other hand, my colleagues, my friends, my compatriots, there are quite a few that they wanted to talk about it. Not everybody is the rabid atheist. Most people are normal people. And they know about the discoveries, but they're just programmed with this methodological naturalism. And it tells you as a scientist that you're violating some integrity of science to open the door to that. And but I had lots of opportunities to talk to my friends, and I still do with some. But people are just terrified to be against science. And so that's a huge barrier that has to be overcome. And thanks for that question.
Yeah, you talk about how unique Earth, the planet is, et cetera, and yet we hear regularly about what are the risks associated with, astral bodies that are coming within the sphere of the planet that could destroy it. And so, how do you kind of work with the concept of the uniqueness in the sense of a perpetual risk?
That's a great question. Thank you for that question. Let me see if I can go back because something I didn't talk about is there's actually a couple verses in the Bible that talk about God preserving the earth. And one of the habitability factors that is recognized as being critical for habitability is to have a really big planet like Jupiter, which is outside the orbit of the planet that's in the habitable zone. So we have been protected by Jupiter.
Okay.
And it's done a very good job. And so I think that's not to say we know that our planet's been hit by some asteroids and comets, but it's still here. And
But even on the planet itself, the period when the earthquakes and volcanoes were causing major blockage of the sun, we could find ourselves being annihilated simply by that.
so one of these critical factors is the amount of radioactive elements that are in the core of the Earth. And that controls two things that are really important. It controls the magnetic field. It makes the center of the Earth liquid. There's a liquid iron core, and that gives us the magnetic field. So we have to have a magnetic field. Otherwise, we can't, it's absolutely critical. We can't survive the radiation from the sun. And if you want to be an astronaut and go to Mars, you better worry about that because they don't have a magnetic field. Mars doesn't have a magnetic field. But so the elements also control, the radioactive elements in the core also control the amount of, they control the amount of volcanism and plate tectonics. And so the amount of radioactive elements is actually really, really small, a really small fraction. And it's fine-tuned because if it were too much, it's in another presentation. There's a paper that talks about the fine-tuning of those elements. And if it were too much, we'd have too much volcanism. We have to have some activity to have plate tectonics.
And we need to have.
And we have to have plate tectonics.
Really,
So it's not,
California.
that's the way it is. But it is a balance. It is recognized outside of theistic minded people. It's recognized as being a fine-tuned balance in one of the Earth characteristics.
Thank you.
Oh, here.
If we all accept that there is a divine beginning, or else we probably wouldn't be here. What is the feeling of thinkers on both sides of the fence about, is God still changing constants? Is God still tinkering with the mechanism? Is God still intervening? And if so, how does he decide when to intervene, not to intervene?
That's a great question. And it's really relevant because I mentioned there's a revolution in biology that's happened recently in the last 10 or 20 years. And part of it comes from the fact that all the DNA that used to be called junk DNA is known to have function. and it's involved with regulating genes. And another big contributor is the fact that, so we have 20,000 genes, but we have many more proteins than that. We have, it depends on how you count them. And there's the reason that is the genes are actually not just simple units that are independent along a string of DNA. There's an editing process, cutting and splicing process. And there's a machine called the spliceosome, which is an amazing thing. And it somehow it knows which, in different cells of your body, the same gene will produce different proteins. But how does it know what to do? Where's the code for that? Okay, now this gets me to your question, because there is a guy who just wrote a book making a strong argument that he thinks, I'm not gonna advocate this, but he thinks that there isn't enough information in a fertilized egg to account for you. So I'm not there yet, but he thinks it. And so that's addressing your question. So he kind of believes now that there is something going on that's outside of materialism. There's some information, what he calls it, the immaterial genome. That's the name of a book, The Immaterial Genome. It just came out, and I'm not sure I'm there yet with that, but he makes arguments from information perspective that there's just too much information. Our bodies are not encoded in DNA. Does everybody know that? DNA is not the blueprint. It's like a hard drive on your computer. You can go in and you pull files out, but it doesn't have, it's not an instruction manual. That whole way of thinking is wrong. And so where is the information? And his opinion is, he thinks that it can't be explained by all the chemistry and physics. Now, the same question is involved in the mind and the brain. Because the question of whether, so we have a brain, I think we have a mind as well. But is brain chemistry a complete description of everything you experience? Is everything we do up here algorithmic? Or do we do, free will? I mean, these kind of questions. So I think, at least in those two areas, there are a lot of there's some really intelligent people who make very strong arguments that so this question of incompleteness, some of you may know about Gödel's incompleteness theorems in mathematics. It's a broader concept than just mathematics. Anywhere where there's information that seems to be lacking or not, the information that's in chemistry and physics is inadequate. That is an indication of an incompleteness. And your question is the incompleteness currently, are there incomplete, is naturalism incomplete even through the operation? We talked about the origin versus the operation, but even the operation of the world in our minds, maybe in the development of embryos, could be incomplete as well. So it's an open question. But it's going to be an area of focus because as science progresses, we're learning so much more about the miraculous things cells do, and it's not in the DNA. So where is it coming from?
Do you have the name of the author of that book?
That
was written by Klinghoffer.
David Klinghoffer, but he wrote,
But it's not his.
he wrote the book about the scientist.
Oh, okay,
And the scientist is Richard Sternberg.
okay.
Yeah, I invited him once to come and he spoke at UNM and, but he's had this idea for a long time and he's gonna write his own book. So someone else wrote a book because he was taught, when he came, he was talking to me about his book in 2015, I think. So he takes a long time. And someone else is writing sort of a initial book about it and he'll eventually produce his own.
You know, of course, I'm a believer and I believe that God created the heavens and the earth.
Yep.
But.
Yeah.
Science excludes that concept. But if you're gonna let it in, how would you let it in?
Well, I really like this term of informational discontinuity. And I think it's a well-defined scientific thing. You can either, account for the information or you can't. I feel like it's a well-defined scientific question. And, but when you say, how do you let it in, do you mean,
Well,
is there a mechanism for understanding
No,
how
I
the
mean,
mind and the brain works? I don't expect to know how God acts. But I do think we should be able, if there's an informational discontinuity, I think we can detect it. Did I?
Well, yeah, I was just thinking in terms of, when you're explaining something in a scientific context, right?
Uh-huh.
You know, you're never allowed to say, well, this is where God.
Well, but you could say if the origin of life, look, it's been 70 years, there's no progress on the information part of that.
Right.
The chemistry, it has all kinds of problems. And okay, so well, how long, maybe we go another 70 years, or how long do you, at some point you say, chemistry and physics didn't do this, so what are the other alternatives? And actually, that's what motivated, I mentioned, there's this guy at NIH who wrote a paper about, he said, well, let's just say the infinite universe has produced it. Or a computer programmer. I mean, when you get to this level of type of argument, then I think the notion of God is, it's implicit. Everybody knows it's there.
I've been thinking about this, and I've talked to Mark about it before. But I want to know where my creative spirit comes from. I feel it,
Yeah.
I see it. It's not a doubt. And everything you said has made me think you've given that a lot of thought. I just would like
Yes, so
to know.
that's a great question. It's another really exciting area right now because we have AI. And there's a lot of thinking and research about what it is that we do and what machines do. And machines will always be algorithmic. And so the question is everything we do algorithmic? And I don't think so. I'm convinced that
No,
for me, I'm convinced I do things that couldn't be algorithmic. But I think the question of how you define and prove creativity. So can a computer program, can an AI system ever do something that would be outside the bounds of what the programmers put into it or expected? For example, if you, and I can think of lots of examples and I don't know the answers, but if you trained an AI system on Bach and Beethoven and those, and could it make jazz? Could it produce jazz? I don't know. And so the whole idea of creativity is a research topic. That's of a intense focus. And there's an institute from the Discovery Institute called it's called the Institute for Human and Artificial Intelligence. And there's a bunch of smart people who are trying to address your question.
I'd be interested in more follow-up.
Okay.
I just want to make sure everybody noticed the website there where all of his presentations are linked and videos. So if you want more.
Granville has been the key catalyst in making all that happen, so I really appreciate it.
Yeah, I heard it then.
He was also the catalyst that started intelligent design conversations in this place.
Great, yeah.
Yeah, this whole idea, which is very new, this immaterial genome. Boy, that's a hard topic to wrap your mind around.
Yeah.
But when you're saying that our DNA is not sufficient to account for, let's say, the human body there.
Right.
There seems to be a missing step. Along with this immaterial genome, I read, I think maybe 9 months ago, that some people are saying or discovering that they feel that the whole fabric of the universe has intelligence of some type. What that means and what you can do with it, I don't know, but isn't that a crazy concept? That fabric of the entire universe seems to be information from everything. So,
Well, I would say this, that nobody knows where the natural laws are. We have natural laws, where are they? Where are they? They're in the universe somehow. But I don't-
somehow.
Yeah,
And I'm glad you mentioned your pushback from Sandia. Of course, and others may know that you're not the first. There have been a lot of qualified scientists who have been hushed up. And we're all familiar with cancel culture today, and that focuses mainly on political, sociological, ethical problems. But I gotta tell you, what I think is even stronger is scientific cancel culture. Because coming out of Lewontin, Harvard, and Stephen Jay Gould in the early 60s, I know of only one PhD who was able to get his doctorate from Gould. I mean, you can't do it. The academy, at least in the sciences, has such a strong cancel culture. And I don't know how you're ever going to get around that.
I know that the people in the Discovery Institute, they communicate with a lot of young scientists.
Right.
And they tell them not to kind of keep their
Exactly.
perspective under
Yeah,
the table until you get your tenure.
exactly.
So that's strong advice. I want to make sure I mention one more book. There's a book that came out very recently called How Life Works. And it's by Philip Ball, who is an editor at Nature. He's not an advocate of design. He puts a lot of natural selection type language in that's not very impressive, but he does describe the revolution that's happened in biology. He's not an advocate of design. And so it's a fascinating book. And he uses he believes that we have to use the term agency for any form of life. And agency and purpose and teleology. But somehow he thinks natural selection makes that. But he's really pushing the limits way beyond what was the traditional gene-centric view. It's a great book, How Life Works.
If I heard you correctly, when you talked about Discovery One, you talked about in the beginning, and it was a long time ago. What drives it to be a long time ago versus a shorter time?
So that comes from the fact that you see light coming from distances that are, we know the speed of light travels a certain speed, and we know that there's ways to estimate distances. So so you would have to either say that the light was created if you didn't believe that those events actually happen that we see in the light. I mean, there's some people who believe that God created and all these things like star formation and all the events that we see in the light. Maybe that it just God created it as if the light were already there. That's one. I think you're getting toward the interpretation of Genesis and the different ways of interpreting that. And I have a bunch of slides on that, and there's a website that has described 7 different ways of interpreting. And I've really spent a lot of time thinking about that. And but I think so. I guess the best answer I have for you is that microwave background radiation, if it really did come from that transition from a plasma to recombination, that pretty much defines the time scale. Because for the universe to go from 3,000 degree Kelvin for that radiation to go from 3,000 to 3 degrees, there's an expansion factor, and we measure the rate of expansion with the Hubble constant. So it's pretty much in those numbers.
Hey, Doug, to your question, John Lennox wrote a really good book called 7 Days That Shook the World.
Yeah, I recommend it.
Yeah, you should look that up and check it out.
It's a good one.
He's a mathematician from Augsburg. What an apologist.
I pay a lot of attention to what
I never knew myself. He's a great guy. He's on YouTube.
Any other thoughts?
What guidance would you offer in, most of us here have a technical education, we've earned our living doing this. And so what guidance would you offer in terms of when do you say, this really is a science related problem, 2-body problem, 3-body problem, whatever it is that the science really is dominant in. And when do you say, nah, this is something where there's more than science involved. There's religion, there's divinity, there's a whole bunch of things that are not going to be described by science. But we all have to balance those things off. And how do you recommend we try to do that?
Well, I think everybody has their own way of thinking about it, and I've progressed a long way in my thinking from where I started. And I have a strong, because I was a research scientist now, I have a very strong desire or I would say position that I really believe in this view of 2 books of nature. There's the book of God's words and the book of God's works. And I really feel very strongly that you have to let science be science and not try to take your understanding of science and manipulate it to fit what you think is your best interpretation of scripture. I would prefer to let science be science, and with the idea that yes, science is a human activity, so it's limited. It's not perfect. But interpreting scripture also has some challenges, and that's one of the topics of the book that he mentioned by John Lennox. He talks about the famous example where 2 very important theologians both rejected the idea that the earth went around the sun, because there are some verses in Psalms that speak to that. And so I think it's prudent. It's my opinion as a scientist. This is where I'm going to go. I want to let science be science and let the data be the arbiter. So this is what I tell the people who are on the other side. I say, don't impose methodological naturalism. Let the data be the arbiter. Well, I can't say that and then say, except if I don't like the data and I want to, you can't do that. So I really want to let science be science. And, but I think I'm really impressed with the harmony that there is between scripture and science.
You know, in a mirror image view, when you were talking about the information insufficiency of the human genome to make me, or Ed.
Yep.
My mind immediately went to, well, what would fill in the gap?
Well,
And in my mind, if I may,
Right.
in my mind, as a something of a theologian, I would say, well, you've got the human soul, right? It's the touch of God that makes this happen. And then I think, well, what about the common squirrel? The squirrel out there also has an information insufficiency. So maybe my brother in the back was right when he said, spark of God is in each living thing, and something unnamed, but that spark of God informs the squirrel how that squirrel is going to be. The problem with that, and it's the greatest irony of this evening for me, is that the great theologians of the church will not hear of a soul in a non-human living thing because it's the same dynamic. It's the other side of the coin.
I know, right?
All dogs go to heaven.
Yeah, all dogs.
But on that topic, you know, you mentioned the genome, but there's also information in the fertilized egg that comes from the mother. And so you have to consider all that together, but all that together, is it, you know, your fingerprints aren't in there. And so there's really exciting questions from the biological side, but I tend to think that they're not machines.
Hmm.
There's something more, even in a
Yeah.
bacterium. But
I would agree.
So are you suggesting the miracle of birth is a miracle?
I think there's a lot more gonna be coming out about how much you can explain from the, you know, tracking the information, the fertilized egg. And there's a lot of stuff that happens and nobody knows what happened. Where's the, you know, people use the analogy of like a conductor conducting a symphony. Like the gene expression is like a symphony being conducted in all the different tissues. Who's the conductor? Where is the conductor? Nobody knows the answer. And that's where it's at.
Hey, Mike, do you know Mike Ignor from the Discovery Institute, the neurosurgeon?
Yeah.
Well, to your question, Mark, I just sent both of you a wonderful YouTube with him speaking.
He's a great.
Oh my goodness, I saw him in person. That guy had operated done brain surgery like 8 to 10,000 people. And his observations concerning the immaterial soul and different things along that, it'll blow your mind.
He just wrote a book.
Yes, exactly. I
And it's-
recommend that book.
I haven't read it yet. So it's on he's a neurosurgeon. He's a lot of experience with brain surgeries and deformations and he has a lot to say about the mind and the soul and so it's
What's his name?
Michael Egnor,
EGNOR.
EGNOR. And he's a great person to, if you're interested in this topic, he's one of the best to read.
Well, let me offer an apology first. In our rush to get things started, I neglected to begin us with a prayer, so may I offer a prayer of blessing. Oh, Lord God, we give you thanks for this evening, and we give you thanks especially for Michael and all that he has offered us. The consideration of your word come to fruition through the human mind and the human wonder and experimentation of the world you have made. Each time, dear Michael has opened up another layer for us to consider. We find you. And so, Lord God, as we go forth from this place, may we find you in everything we see, especially our sisters and brothers we find all around us in this world. And as we see that spark of life that you have put in them, let us serve them and love them, for you are the God of love. And again, guard us all as we go forth from this place and give us the courage when somebody says that's unhearable to speak the word anyway. And in so doing, bring that love that flows only from you out to all, that we may share it and flourish in it. In Jesus' name we pray. Amen.
Thank you. Thank you.
Thank you. Thank you.
Thank you.